All right. Hello, hello. Another day, another stream. I realized that having a starting soon screen is a little bit silly, so I just have NeoVim pulled up with what I want to get done. I think it's the parser. I'll check. I just leaked all my files. That's huge. Where does this live? Code. Parser, yeah. So yeah, it's gonna be a good time. I get to keep working on the stuff I want to work on. Leetcode. Something about a daily check-in. Power 4. It really is Power Week, it looks like. Let's close out of this. So if we just even go to like the LeetCode problem listing, even if we go here and we look at the questions from this week, there's power of 2, there's reordered power of 2, more powers, more powers, more powers, more powers. It's all just different flavors of powers, it looks like. So yeah, guess it's Power Week. Okay. Return true if it's power 4. This problem seems a little bit familiar to me. I'm not really sure why. So we have. Let's see if I remember how to one-line this. So it has to be greater than 0 to be a power 4. Because you can't really get a negative number from a power of 4. And we can't get 0. And then where to go from here? I feel like I should remember this. I don't know why I'm not remembering this. I literally did this 2 days ago. And mod. Okay, let's get the largest power of 4 that fits in this. So we have the int limit. Let's just do this by hand. This is the largest power 4 that fits. N is greater than 0. Or no, equals 0. Yeah, this problem's a little bit silly. Oh, wait. Wait a second. Wait. Wait, no, it's not silly. Wait. Do I just have to explicitly handle n is not 2? Let's put this at the end, actually. Oh, that's okay. Okay, I see the problem now. And divide by 2 is maybe we just have to make it not divisible by 2? Is that? Wait, no. Wait. Divide by 2 must also equal 0. Yeah. Wait, no. Wait. Hmm. Okay, this is actually meaningfully more difficult. I can't actually just one-liner this, it looks like. So how do we filter out the ones that are powers of 2 but not powers of 4? It's a power of 2, then so let's just filter out 1 and by 2 or let's take that number again. Uh I know this doesn't make uh why am I like wait. Text wrap, my favorite feature. Okay, let's try again. Okay, where do we go from here? N divided by so it has to be greater than 0 still. That's a given. And then How do we approach this? So it has to be a power 4, but it can't. Let's just do it the lazy way first. Is there a missing parenthesis? There it is. Wait, this is constant? How's this constant? Wait, this shouldn't be constant. This doesn't. I guess it all folds, but like still. Okay, so what's the actual fast way to do this? Hmm. There's a bit manip way to do it. Oh, okay. Interesting. Okay. Wait. I think actually we can take that idea and extrapolate it a little bit more. Hello, Steven. Appreciate the sentiment. Decimal to binary. So so keep note of the 0, 0 here. 16. Oh, wait, that's cute, actually. That's quite nice. Okay, so we can check that n minus 1 mod 3 is 0, and then an even position. Makes sense. Wait, that's pretty neat. I guess that's something I should know. Wait, that's really cool, actually. This is gross. Wait, what is... Wait, what are these solutions? Hi, Janine. How's it going? I am trying to write code that checks if a number is a power 4, but I tried doing it um I tried doing it the same way I checked if something was a power of 3, and it didn't work because powers of 2 are also included. Um so I did it the lazy way and it worked, so now I'm trying to do it the fast way. We're trying to figure out what the fast way is. Long time no see. I agree. What's this extra filter thing? Oh, that actually makes sense. Cause yeah. Okay. Uh what? Huh? Am I missing something? Is it actually the parentheses? Yes, it is. Okay, this gives me a good chance to review C++ operator precedence. Interesting that this is worse for memory. Yeah, I guess that makes sense. Because this has like more random stuff calculated, whereas my previous submission, um, this one just relies on the compiler to do a lot more of the work, so it has less active bits in memory, I guess. But this is like technically not optimal, which is kind of funny to think about. I'm gonna post both later, but that's a future me problem. So, anyways, that's one thing checked off the list. The code took less than half an hour today, which is quite incredible. Um, the other thing that I wanted to work on was just finishing up um the kaleidoscope parser. This is not the right one. Yeah, okay. Yeah, so I haven't made any additional progress since last time, but yeah, I guess I get to write more code. Uh, where's kaleidoscope? There we go. let's get the parser done. Also, shout out Steven for supporting me. Of course, the thumbnail is me staring at a compile error after forgetting a parenthesis. Okay. Okay. This light mode stuff on LLVM is like really bothering me. So I'll probably deal with that after this, but yeah, I'm sure there's like some plugin to handle this for me. Or like some Firefox plugin. If any of you know of anything to make Sphinx not be gross like that, please let me know. This is Sphinx generated, right? Yeah, Sphinx. Yeah. Wait, Linux kernel? Huh. How about that? Anyway. Anyway, where was I? Binary expression parsing. No, I lied. One more up. Basic expression parsing. So what we ended up with last time was so before last time we had the lexer made, which reads text and turns it into quote unquote words or tokens. Last time we made the AST, which is sort of the definition of what sentences are. So now we need to take those words and combine them into sentences. So that is the job of the parser. And last time we made the AST and we started the parser. So we have like the parser object and we have it able to get the next token, but we have hard time envim. So yeah, we made it able to get the next token and we made the object exist, but we haven't actually done anything with it yet. So that is what today's goal is, to completely finish the parser. We have a lot of time to do that, so I'm not that concerned about that. If I could get it done within an hour, that'd be great. If I could get it done within 1.5 hours, then that's fine though. Any more than that, and I fear I would have to go get dinner first. So let's start with this. Let's start with the headers. Unique. So this makes a X per AST unique pointer for parse number X per. And then parent X per. Is there a generic parse expression? Where is it? Oh. Wait, where is parse expression? Parse expression. Eh? Wait, what? Oh, it's forward declared. I see. Where's the first time? Does it mention? It doesn't mention it. Interesting. Okay. Yeah. So a little bit of a quick explanation as to let me zoom in here. So if we go down to the code here, if we look up parse expression, hidden, I'm about to explain what for declaring things is. So here we have parse parent expr and we have parse identifier expr, and they both call parse expression. But if we scroll down to parse expression, it calls parse primary, which I believe relies on those two, which also relies on parse expression. So we have a sort of circular dependency issue here. And the problem is if we put parse expression above parse parent expr, or parse identifier expr, if we put it above that, there will be an error there. But if we obviously we can't really use parse expression before we've declared it. So the solution is to literally just tell the compiler that parse expression exists first, and this is for declaration. And yeah, this gets around the whole, I guess, circular dependency issue here. And I can't wait to have to deal with that issue soon. So yeah, this came to mind because starting here, we are writing functions that contain parse expression without having seen it before. So let's make these headers first. And then let's just yank these, paste them here. I feel like I should have a hotkey to. I feel like I should have a hotkey to just copy these over from the header, but as it goes. Parser, that's what this is called. I'm still getting completely bonked over the head by hard time nvim as planned. So what does this code actually do? Std make unique. This is it makes a unique pointer. Okay, sure. Make unique. Numval. Is this a field? Where did numval come from again? Numval. Did I forget something? Oh, it's in the lexer. I see. Whoops. I saw the word eat. Yeah, I'm hungry. Anyway. Use J instead of 1J. That's wonderful. I'm really not regretting my choice whatsoever. Anyway, where was I? Lexer dot get numeric value. So that's where numval comes from. And then this looks so funny. Just the half Kirby face. So So we get the result, get next token, and then we return the result. And then we do something similar here. We call parse expr early, I think. I think here I don't need to worry about the for declaration issue though, because I have everything declared in a header. So since we're importing the header, that sort of serves as a global for declare of some sort. So at this point, as long as I have parse expression in here, which I should probably have here, let's put it at the end of this. Where is parse expression? Where is this declared? There it is. So everyone's favorite unique pointer. So now that exists, we can call it here. Yeah, this is simple. Okay. Should probably be reading the things that it actually says. One, it shows how we use log error. Current token is a that token open parenthesis. It does need to account for the lack of a close. Okay. So it just eats until null, I guess. Or I guess it eats until it finds a closed parenthesis. And if it doesn't find one, it just returns null, I think. Uses recursion by calling parse expression. Handle recursive grammars. Okay, yeah, that makes sense. So we can nest parentheses. Yeah, the more I think about it, the more I realize I really should have made an expression type in my personal compiler. Yeah, this was a little bit troll, but sure. Mistakes were made, but we will deal with it. So this gets, so currently in the buffer there's a parenthesis token, so we get next token, and then we parse expression. Okay. And since we declared parse expression in the header here, we can use it freely here. So if it's not v, return a null pointer. Actually, we can. Let's make this unreadable. So we've handled the parentheses. So let's assume we have like in parentheses 1 plus 2 here. So when we call, oh god damn it. When we call parse parent expr, we're on the opening parenthesis. When we call parse expression here, we're on the content inside here. We're doing a good job. So the parse expression handles everything inside. And if something fails there, we return a null pointer. And then after it handles everything inside, if it's not closed with a closing parenthesis here, then we log an error. And then we eat up the close parenthesis, and then we return the inner parsed expression. So that makes sense. So given that logic, if flexor cur flexor get talk. Okay, we need to take a quick break to fix this up. Because I didn't think we needed to... Actually... Kurtalk. Where did I get Kurtalk? So it turns out deviating from the tutorial makes it a little bit difficult to follow the tutorial. So let's go back a little bit. Where does this come from? Oh, right. It's... I'm forgetting what my code does. This is a great look. We have Kurtalk up here. We're doing great here. We're doing great out here. It's not Lexer, it's just Kurtalk. Also, a funny thing that I'm sure none of you were wondering is why in here I have ligatures on, but in my NeoVim I don't have ligatures on. The answer is I don't like ligatures, and I was too lazy to turn them off for Firefox. So we will have that discrepancy to deal with. Log error. I just tried using an arrow key. I feel like it's not that bad to use arrow keys when you're already in insert mode, because like if you need to literally move one character, it feels even slower to hit escape, H or L, and then like A. I guess if I'm going back a character, I can just hit escape and then insert. But if I'm going the other way, it seems a little bit insane. I don't know. It's semantics. So we eat up the closing parenthesis and then we return the value. Okay. So we have parent expr now. I don't actually have a way to test all of this yet, so we will just build the plane completely and then see if it flies or if it crashes into the lake. All right. Handling variable references and function calls. So we have parse identifier expr and parse primary. Oh wait, there are different things. I see. Okay, I guess that makes sense. So we need to figure out if the identifier is a function call or if it's just a variable, which I guess that makes sense. I guess all of this is quite interesting to me because I've actually never like written a parser / lexer completely by hand. I've always just used parser generators like pegtool and PyParsing. Don't question what I was doing in Python. If you think too much about it, just don't. Yeah. We need to add this to the header first. And then I guess while we're at it, we may as well just add the other one so I don't have to think about it. We could even add all of these. Bin op precedence. Okay. Right, we could just do this in one shot. Huh. This seems a little bit silly. This helper function seems a little bit silly to me. Oh, right. As we were saying, parse expert here. Okay, maybe I'm getting a little bit ahead of myself. Maybe I should just finish these two first. So let's put this here. Parser. So what's happening here? So we get the name. We eat it. Eat identifier. Me when I eat identifier. Okay, so if there are brackets here, or if there's not brackets here, it's just a variable reference. Otherwise, it's a function call. Okay. Okay, that makes sense. That seems reasonable enough. So is there a reason we need this? Oh, right, because we're eating up the... Okay. Parser, not parser, lexer dot get identifier value. I keep forgetting the parentheses and if statements. That's the mark of someone who's written too much Python. Ugh. There's got to be a faster way to just do that. Make unique. What are we making unique? Variable expr. Ugh. And then we take identifier. I don't like the word identifier here. Let's do name. Okay, what else are we at? Hard time is really fighting me here. This is like completely expected, but also it's like, youch. Let's Oh, I don't like that actually. Maybe I should fix these real quick. I had one more of these up here. There we go. Anyway, where was I? I guess I should probably comment something here. Ah, yeah, arrow keys are not allowed. Yeah, who could have seen that coming in a plugin that makes it harder to use Vim the wrong way? Anyway, where was I? Right. So we eat the parenthesis, and then okay. So now I feel like it's a bit. Surely you could write this in a way that that just uses a while loop. Or no, this has a while loop. We could write this in a way that doesn't use while true. While per token. So let's just make the while condition that it's not equal to close parenthesis. Oh, we need args. So we need a vector of expr ast unique pointers. Okay, let's break down this while loop. So let's just paste it here so I can read this a little bit better. So this section is, so let's parse an expression. If it fails, then we return a null pointer. If there is a parenthesis, then we break there. So wait, so this handles the current. So this handles the stuff inside the parentheses. So we have we have call foo 1, 2, and then the third param is 1 plus 3, 1 plus 2. So this while loop handles everything inside the parentheses here. So we start with, so we parse expression, and if it exists, we add it to the existing the args vector. Otherwise, then this is invalid. So we return null pointer. And then so then it goes to the next character after that. So if it's a closing parenthesis, then we break. If it's not a comma, okay. Okay, and then comma, we just eat the token and continue, it looks like. That's what happens. Okay, so back here. So let's huh. That seems inconsistent. You'd expect there to need to be an extra. You'd expect there to. You'd expect it to require another set of parentheses surrounding like this, but I guess not. Um. Okay. So let's push back. Stood move arg. So that handles that. And then we break on parenthesis. Uh. Okay, I see. I feel like there's a better way to make this logic a little bit cleaner, but I honestly don't care enough, and it seems serviceable. Expected. Yeah, I mean, the more of this parser I write, though, the more I feel like I'm just going through my programming languages class again, which completely makes sense because that is like completely parsers, but also it's like, man, log error is lowercase. The next token. So after that, we need to get next token to eat the closing parenthesis. And then we make a unique pointer to this. Name. So call expr takes name and then the args, I believe. Aha, yeah. Okay. Look ahead. Yeah, I guess the more I think about it, we do have look ahead sort of written in place. So now we do parse primary, which I don't know what the intent is here, but I guess I should read it first. Primary expressions. Ah, I see. Okay, that makes a lot of sense now all of a sudden. Is this in 2.6? Yuck. Okay. Let's just make this a thing. Just parse primary. So default case, we return. Yeah, I guess the parser is what handles all of the error handling. I was curious as to why the lexer didn't handle it, but honestly, the lexer does not care about whether the words are correct. It just breaks it up into words however it possibly can. And if something is not a word, then tough. Tough, I guess. And it's the parser's job to handle that. That makes reasonable sense to me. So wait, there's a that key. I forgot to semicolon. Case hook identifier. So this is sort of like the engine that ties these three functions that we just wrote together, it looks like. So we're just going to do all three of these. That one is, these parentheses things are really irritating me. I'm gonna need to figure out what other Vim users do to make this less miserable. It's more obvious way I can assume the state of Kurtuk. Parse primary. Okay, this makes sense actually. These are just like all the expressions we expect here. So these are like sort of the atomic operations, it looks like. So now we handle binary expressions. They're often ambiguous. Yeah, everyone's seen the Twitter memes on people struggling with basic order of operations. For better or for worse, that is also a problem here we need to deal with though. So it looks like we need to use operator precedence parsing. What is operator precedence parsing? Parses either x plus y times z or x plus y times z. Yeah. Okay, this seems pretty reasonable, pretty human, pretty standard. Elegant and efficient way is to use operator precedence parsing. These are the precedence of binary operators. I should probably look this up real quick. If this problem has taught me anything, I should look this up. Okay, scope resolution, increment. Okay, this seems reasonable enough. I can't lie, I always use suffix slash postfix, increment and decrement. I never use prefix. I don't know why. Okay. Pointer to member. That seems reasonable. Is there a good way to remember this? So what's going wrong in this? Whatever. I just and was equality triggering first? Was that what was happening here? Aha, that's what it was. These two. Okay. That makes sense. Well, I guess I will probably make the same mistake again in the future, but I will make an effort to not make the same mistake in the future. Yeah, okay. Can I just define this map? I need to import unordered map still. So how do I do this again? How do I initialize with commas in pairs? I see. Anyway, let's try this again. Maybe I could do this in the enum, but why? That's 10. Let's make 3 of these. This one's plus, this one's 20. This one's minus, this one's also 20. And then this one times, and this is the highest. This is 40. I feel like I should reverse the order of these, so it makes more sense in my head. from highest to lowest precedence. So you evaluate upper and then down. So then okay. So we need to get toke precedence. It looks like. Let's also get rid of this real quick. Let's put this up here. And parser, get token precedence. Where is ASCII live in? C type again. Okay. So if cur token is not ASCII, then we return -1. And token precedence is precedence of cur token if what does this return if it doesn't exist? Map bracket operator default. This seems a little bit gross though. I don't really like the way this is defined. This can obviously be extended by you, our brave and intrepid reader. Now start parsing binary expressions. Yippee. I feel like this is bad design though. I'm gonna ask Gemini. Wow, Gemini's not really helpful, low key. It supposed to only. Hmm. Okay, wait. So I'm actually correct. Wait, this is quite important. So we actually shouldn't use the bracket operator. Auto pair equals precedence dot find per token if pair spin off precedence dot end. So then it doesn't exist. So when we can return -1 here. Okay, thank you, Gemini, for being validating. Okay. So this does what we need it to. And then we took precedence exists here. Okay. So what do we do from here? Now start parsing binary expressions. Here's the ADO operator. Precedence parsing is the breakdown expression. Okay. A stream of primary expressions separated by binary operators. Okay, that makes sense. So parse A. Then it'll parse plus B and plus, and then in the brackets C and then plus D. So plus that. And times E times F and plus G. Okay, that makes sense. And then this literally brackets away this to worry about at a future time. Yeah. Let me check something real quick. Okay. Thought my stream did an oopsie. Yeah. Maybe I should have done something like this for my personal compiler. So primary expression followed by a sequence of those pairs. Ew, and then parse expression handles like all of them put together, it looks like, is what I'm getting from this. Yeah, so parse parent needs that, and then yeah, okay, that makes sense. So let's keep going, shall we? So we finally get to define parse expression. Oh, it just occurred to me, if we have a pair, I can just closing bracket to move forward instead of having to do whatever gross stuff I was doing before. So we parse primary if not first. So if first fails, it'll be a null pointer. Why are these up? So let's do a fun little find replace here. So I want to change all of the uppercase P's in parse identifier expr, number expr, and parent expr. But I don't want it to hit parser. So all of these parse is followed by. So the only one we don't want to match is when parse is followed by a lowercase r. So find and replace parse, and then not lowercase r. We should put that in a group. Lowercase, and then yeah, that needs to be in a group. So in a group, we have not lowercase r. Then parse, and then 1. So 1, 3, 4, 5, 6, 7, 8, 9. And yeah, what a find and replace. Ugh. There we go. First try. So if that doesn't exist, we return a null pointer. And then from here, we return what we will call the right-hand side. Why does this matter? Oh, I see why this matters. Parse primary rest. I don't want to call it bin op right hand side. Parse expression rest. So 0 and then first. So we need to make this a thing. Let's actually make this here. int min precedence, and then a unique expr is t pointer for all the stuff we've eaten up. How does this work? Pass in plus x. Okay. Okay, so what's happening here? I should probably walk through this. Let's this here. Let's make parse expression parser parse expression rest int min precedence, and then a unique pointer of what type is this? Expr AST. We'll just call this previous, actually. That makes more sense in my head. Min precedence. Oh. Okay. Oops. What else do I need here? Okay. I need to fill it in. That's what I need to do. I think while true here is like justifiable. Precedence is get precedence. So it's less than the min precedence. Turn left-hand side. Return prev. maybe I should read through all this first before actually figuring out how to implement this. So let me just move my stream window real quick. Okay. So this gets the precedence of the current token and checks to see if it's too low. Because we define invalid tokens that are precedence of -1, this track implicitly knows the pair stream ends when a token stream runs out of binary operators. Okay, so that's the default case. If it succeeds, then we know it is a binary operator and it'll be included in the expression somehow. So this is the entry point at least. So so we get the binary operator and then we parse primary. Not right hand side, return null pointer. So the next one. Okay, I should just read this. So we get the next precedent. We get the precedence of the next token, and if that one's larger, then that means we handle that one first. Okay. Okay, that makes sense to me. Okay, well, this one's a bit of a doozy. So it might just be a little bit more sane if I just parse this entire thing first. Or not parse, if I write the entire thing first. So then the binary operator is the current token. Get the next token. 1 second. Okay, well I got a knock on my door and I'm not sure who it's from, so I'm just gonna keep going. Yeah, anyway. Let's get next token. 1 second. Okay, I'm being asked to open my window. I'm not sure why I couldn't have just gotten a message for that, but I guess that works as well. Does my camera show outside? It doesn't look like it does. Okay. I can safely raise this blind without doxing myself. Sure. Let there be light. Ah. What exactly is a kaleidoscope parser? Kaleidoscope is the LLVM. So the thing I'm following is LLVM's tutorial for writing a language front end. So it is a, I guess, mini compiler that turns a language into LLVM, which is, I guess, the compiler language. And then within here, uh, Kaleidoscope is the source language that we're using. So I'm writing a parser for Kaleidoscope so that I can write a front end that translates Kaleidoscope into LLVM. Yeah, this language is quite simple, roughly it looks like. I don't think the white space is actually significant, is the interesting thing. Because if I, where am I? So if I go to the Lexer, there's a place I handle white space. Is space? No. Getting bitten by the thing again. Kaleidoscope to, yeah, correct. Kaleidoscope to AST into LLVM. Yeah, it looks like white space isn't significant actually, which is interesting. So you could theoretically stick all of this in one line. Very basic parser Lexer for JSON. It's quite fun. I mean, fair enough, yeah. JSON's definitely worse to write than it is to parse, because it's quite well defined compared to something like Python where white space is significant. Generally, I feel like the rule is if you can write the entire language in one line and ignore white spaces, the parser is not that miserable to write. Yeah, me and my homies hate white space. Anyway, where was I have the page down key that I can use. Aha. Okay, we're here. So we know it's a binary operator. So we eat the binary operator. And we parse the primary expression. So I guess I should probably figure out what's happening here. Python superior, that's so real. We love brackets. So we have an expression here like 1 plus 2 plus, let's make it complex. 1 times 2 plus 3. Or 0 plus 1. Yeah. So we have, so it looks like there's 3 types of primary expressions. There's a literal number, there is a variable, and then there is stuff in, or I guess another compound binary expression in brackets. So like 1 plus b, for instance. So these are primary expressions, I guess. What's the fancy way they, yeah, that's the technically correct way to notate it. Something about an EBNF. I don't know what an EBNF is. So then an expression is equal to primary, and then optionally operator, and then an operator, and then another primary, it looks like. So in this example, 0, 1, 2, and 3 are the primaries, and then this whole thing is an expression. So the way we're parsing it So this is like, so the thing we have to worry about here is operator precedence. So we'd have to evaluate this multiplication before the two additions. So that's what this stuff handles. I guess that's a helper for that. So the entry point into this, it parses the first primary, and then we parse the rest of the token stream, and then we give it. So we parse it, I guess, operator and then primary at a time. So operator primary, operator primary, operator primary. So currently we've eaten up the 0. And then it calls right-hand side. So it looks at the current token, it gets its precedence, and then we've initialized the default value of unrecognized tokens or unrecognized characters as -1. So if it's smaller, if its precedence is smaller than the minimum that we pass into this function here, which we default as 0, it just stops. So that's how we break at like parenthesis or something. And otherwise, we know it's a binary operator. So we keep this one. So we have a 0 here, we have a plus here, and then we get the next token. So this would give the 1. I guess we parse it here. We parse the primary. So here is the 1. And then if there's an error there, we return a null pointer. So we check that it exists. We get the, then we peek ahead, it looks like. Yeah, so we look ahead at the next binary operator to determine precedence and compare it to the current one's precedence. So the look ahead here is times. So if we think about this section bracketed off here, we're currently at this one. This previous plus is lower precedence than the times. So what we want to happen here is we want these two to be evaluated. So if it's less than that, then yeah. So if it's less than that, we if it's, wait, what is happening here? So easier case to start with if it's not. So let's look at this one here. So we want to collapse the right side at this. Oh yeah, actually this makes sense now. I think this also kind of explains why C happened to evaluate right to left. So if the next one is lower precedence, lower or equal to, I guess, because less than would be just if left is strictly less than right in precedence. So if the right hand side is lower precedence, then wait, am I reading this right? Left hand side is, okay, I have confused myself. 1 second. So the precedence of this stuff is lower or equal to the precedence of our current operator, then wait. How do I have it laid out here? So higher precedence is bigger number. So if the current precedence is less than the right side. Ah, I see. Because this paragraph is describing the stuff outside of the if body. So if the right side is less than or equal to, so this case here, for instance, there I am. So in this case, then this looks wrong. The precedence to the right is lower or equal to. Oh, I see. Yeah. The sentence is kind of trivial, actually, it looks like. Yeah. So if the right side is lower precedence, such as here, then we evaluate the stuff on the left first. Yeah. So unfortunately for MeBrain, it turns out that you are in fact supposed to evaluate multiplication before addition. So yeah, we're yeah, don't be a math major. I'm not a math major. Yeah. So we can. So in that case, we know the left stuff is bracketed. So then we can create that node. And then otherwise we handle the right side stuff first and then we bracket it all together. So if we go back here, in this instance, since the right hand stuff has higher precedence, we want to first evaluate the stuff starting from here first. So we evaluate it until here. And then since this plus has lower precedence than the star, we sort of close the bracket here. And then we evaluate this all as one big plus. And then we finally bracket around all of this. Okay. Okay, yeah, that. So we go back here. Let's give this another shot. Now that I actually have some idea of what's happening. So yeah. So we've gone to here. So then equals parse prime. So the next primary is parse primary if next fails, then we return a null pointer. So now we do the precedence comparison stuff. So int next equals next precedence is get. So we get the precedence of next operator if cur precedence is less than. So we don't care about that yet. We'll handle that after. But regardless, so So the current precedence is less than the next precedence, and we have to evaluate the next first. So we recursively call parse expression rest on that. And then once all of the right side is bundled up into something that is lower precedence or lower or equal precedence, then we merge. So here we merge first. What's the prem here? Prev. Damn it. Make unique. So now we make a binary expression node. So it has the binary operator for the binary operator, and then so now we move previous into here because these are unique pointers, and then now we move next into here. And then this loops back around. So now instead of filling in the if function, I'm gonna get walled out by my bad habits thanks to hardtime.nvim. So then next equals parse expression rest with min precedence plus 1, or wait, no, cur precedence plus 1, because we're only evaluating the inner precedence. So in this example here, if we remove all the brackets, so we have a bracket here. We want it to see the plus, and I guess here the minimum precedence is the same as the plus here. So we want it to, in the event that it like keeps going, we want it to stop at anything that is outside the precedence of the current inner scope, sort of. Poor explanation, but oh, I just made a temp file. Okay, great. I'll clean that up later. Current precedence plus 1, and then we move not right hand side, next into here. Right, next. Yeah. And then if there's an error, and then okay. So now we're supposed to return something, right? I think we're supposed to return something. It's a pretty good chance we're supposed to return something here. Right? Do I need to return something? Oh, it returns something inside. Okay. Okay. That makes sense. Yeah, okay. Now the binary operator, primaries, higher precedence. Okay. So the inner function recursively processes it, which makes sense. Plus G piece. In this example. Okay, yeah. Okay. We just have a little bit of stuff left. I really should get food, but I'm feeling like finishing this up, so I'm gonna finish this up. Not an expert AST. So now we parse prototype. So this is necessary for both extern function declarations and function body definitions, which makes sense. So let's put this here. Not sure why this didn't autocomplete. Okay. Yeah, this statement here is quite true. So we get the identifier. We check for the brackets, and then we push identifiers. Success. Okay, great. Then this returns an error. Log error p. Yeah, okay. Nothing special there. Not parser. Lexer get identifier value. Get next token. And we do another check. So We make a string vector of args. This is actually arg names. That actually makes sense to me. Arbitrarily. So all these are identifiers. I don't need the brackets actually. Actually, let's just copy this. Wait a second. Whoops. Anyway. So now we eat next token. So now we make this a thing. That seems wrong. It's definitely used. Guess not. I guess it isn't used. Fair enough. Alright, we are so close to done. We just need to add extern and we need to add functions. We're top level experts. And then functions. Yeah, we need functions. Parse definition. Expert. Then this one is extern. Wow, this is this is a little bit silly. My sister is playing piano again. Everyone clap for my sister. I'm just gonna go quickly through these because they're not really interesting. parse prototype. So we get a prototype. Pointer if auto expression. Okay, yeah. So if we get an expression, then we make the thing. Otherwise, we turn null putter. So this has a prototype and expression. And what else is there to do? Parse extern and parse top level. Extern is a little bit stupid. Get next token. Turn parse prototype. And then arbitrary top level expressions. So we have auto ease, parse expression. Make an anonymous proto. Okay. Okay, yeah. Let me get used to using the tilde on here. So we make that. Vector of string. So we have the prototype now. Now we just need to make the actual anonymous function. So it's prototype, and then it has the expression. Return, otherwise return null pointer. Because then it's not an expression. So we have all of the individual parsing components. Now what we need to do is take them and we just need to like run. We just need to like use them all to, I guess, we need to combine them all into the general parsing logic, which is what the driver here is. Yeah. And then we should probably move all of these into private. So this goes here. And then all right, I gotta eat dinner soon. So we actually gotta zoom a little bit. So the only other public function here is parse. Uh, dinner. I'm trying to figure out what the return for this ends up looking like. Yeah, let me look at this a little bit more closely. Main loop. Oh wait, yeah, this thing we're writing is main loop. Okay, so this is basically just an interpreter, which is interesting. Yeah, and then it looks like in the next one we'll take the stuff. Yeah, so they all have code gen functions. And then if we scroll all the way to the end here, it's a print v module. Yeah, okay, that makes sense roughly. So yeah, we're just gonna get this to a quick close. Next time we'll actually, maybe I just save this for next time. I'll put everything together next time, and then maybe I'll have a little bit of stuff so I can like dump the AST. Yeah, I think that's a good place to call that at least. Yeah. All right. I gotta run off really fast. I can hear my parents calling my name downstairs. So yeah. Yep. See y'all around. See y'all tomorrow. I'll be streaming at the same time probably. If you haven't already, you should like the stream and subscribe. And yeah, right after I eat dinner, I will schedule tomorrow's stream. It'll probably be roughly around the same time. So yeah, see y'all then. Take care.